In our previous lecture, we have learned about saturated hydrocarbons. Today, we are going to learn about unsaturated hydrocarbons. Unsaturated means these hydrocarbon compounds will contain carbon-carbon double bond or carbon-carbon triple bond between them. So, these compounds are called unsaturated because one of the double bonds or one or two of the triple bonds can be broken and hydrogen atoms can be added to those bonds. So they are called unsaturated. That means the carbon-carbon double bond may break and get attached to two hydrogen atoms. Carbon-carbon triple bond, one of the bonds may break and two hydrogen atoms can be attached to that. Let's see an example. For example, ethene. Ethene is CH2 double bond CH2. When one of this double bond breaks, one hydrogen is attached to the first carbon and another hydrogen is attached to the third carbon. Thereby it becomes an alkane, ethane. As we know, alkanes are saturated hydrocarbons. So this is unsaturated because it has a double bond between two carbon atoms and hydrogen can be added by breaking one of the double bonds. So it is unsaturated. Here this is saturated because no bond can be broken to add more hydrogen atoms. So this is an alkane. So alkene has become alkane by addition of two hydrogen atoms by breaking one of the double bond. Unsaturated hydrocarbons are divided into alkenes and alkynes. Alkenes, they contain carbon-carbon double bonds. That is, an alkene will contain at least one double bond between carbon-carbon atoms. Example is ethene. We have just seen ethene. CH2 double bond CH2 is ethene. Ene means double bond. Then alkynes. They contain carbon-carbon triple bonds. At least one carbon-carbon triple bond. So they are called alkynes. Ine means triple bond. Example is ethyne. Ine. YNE. Ine stands for triple bond. CH triple bond CH is ethyne. These are the unsaturated hydrocarbons, alkenes and alkynes. Now let us study alkenes first. Alkenes are divided into two types: open chain alkenes and cyclic alkenes. Just like alkanes, alkenes are also divided into two types: open chain alkenes and cyclic alkenes. Open chain alkenes, they have a straight chain of carbon-carbon atoms, at least with one carbon-carbon double bond. General formula of alkene, open chain alkene is CnH2n. That is, N stands for number of carbon atoms. Number of hydrogen atoms will be double of that. that is open chain alkene general formula. Simplest alkene with open chain is ethene. CH double bond CH is ethene. Because in order to have carbon-carbon double bond, minimum of 2 carbon atoms are required. Since 2 carbon atoms are needed, because we have to show a double bond between carbon and carbon atoms. So the first member of alkene, open chain alkene, the first member of open chain alkene is ethene. Now let's see the naming of the open chain alkenes. They are named depending on the number of carbon atoms they contain. So if there are 2 carbon atoms, the prefix, the name contains prefix and suffix. If 2 carbon atoms are present, it is called eth. Eth represents 2 carbon atoms. Ene represents a double bond. So ethene is nothing but CH2 double bond CH2. These first carbon and second carbon have a double bond between them. Since each carbon needs 4 bonds, first carbon needs 2 more bonds, so 2 hydrogen atoms are attached to it. Second carbon also needs 2 more bonds, so 2 hydrogen atoms are attached to it. So this is ethene, CH2 double bond CH2. Now, if the alkene contains 3 carbon atoms, it is called 3 atoms. Prefix is prop. Prop stands for 3 carbon atoms. Ene stands for a double bond. So, an alkene with 3 carbon atoms is called propene. So, we have 1, 2, 3 carbon atoms and a double bond between first and second carbon atoms and a single bond between second and third carbon atom. The first carbon already has a double bond with another carbon. So it needs 2 more bonds. So 2 more hydrogens are attached to it. The second carbon has 1 double bond and 1 single bond with another carbon atom. So it needs 1 more bond because it needs 4 bonds. So 1 more bond is formed by hydrogen. The third carbon has 1 single bond with carbon atom. So it needs 3 more bonds. So it forms 3 bonds with 3 hydrogen atoms. So this is the structure of propene. CH2 double bond CH CH3. This is propene. So if the alkene contains 4 carbon atoms, it is called butane. But represents 4 carbon atoms. Ene represents a double bond. So the first carbon and the second carbon has a double bond between them. Second and third have a single bond. Third and fourth carbons have a single bond between them. First carbon already has 2 double bonds. One double bond with another carbon atom. So it needs 2 more hydrogens. So it will have 2 hydrogen atoms attached to it. The second carbon has a double bond and a single bond with carbon atoms. So it needs 1 more bond. So 1 more hydrogen is attached to it. The third carbon has a carbon-carbon single bond and another carbon-carbon single bond. So it needs 2 more bonds to become stable. So it will have 2 hydrogen atoms attached to it. The fourth carbon has a single carbon-carbon bond. So it needs two more bonds to become stable. So three hydrogen atoms are attached to the fourth carbon. So butene means CH2 double bond CH, CH2 single bond CH3. This is butene. Let us see the next member of the cyclic alkenes. The next member contains 5 carbon atoms. So it is called pentene. Pent stands for 5 carbons. En stands for a double bond. So the first carbon and the second carbon have a double bond between them. So first carbon needs two more bonds. So it forms two bonds with hydrogen atoms. So the second carbon has one double bond with the carbon atom, first carbon, and a single bond with third carbon. So it needs one more bond to become stable. So it has a bond with hydrogen atom. The third carbon has a single bond with second carbon atom and a single bond with fourth carbon atom. So it needs two more bonds to become stable. So two hydrogen atoms are attached to this third carbon. Similarly, fourth carbon has a single bond with third carbon atom and fifth carbon atom. So two bonds are there. It needs two more bonds to become stable. So it will form two bonds with hydrogen atoms. Two hydrogen atoms. Fifth carbon has one carbon-carbon single bond with fourth carbon. So it needs three more bonds to become stable. So it gets attached to three more hydrogen atoms. So this is pentane. Pentane is CH2 double bond CH, CH2, CH2 and CH3. The next member of the open chain alkene is alkene with 6 carbon atoms. It is called hexene. Hex stands for 6. En stands for double bond. So it has 6 carbon atoms. 1, 2, 3, 4, 5, 6. So this is a first carbon and second carbon has a double bond. So it is called hexene. As usual, each carbon atom needs 4 bonds to become stable. So first and second carbons have a double bond between them. So the first carbon needs 2 more bonds. So it gets attached to 2 hydrogen atoms. Second carbon needs 1 more bond. So it gets attached to 1 more hydrogen atom. Similarly, third carbon has 2 carbon-carbon single bonds. So it needs 2 more hydrogens. So it gets attached to 2 hydrogen atoms. Similarly, the remaining carbon atoms gets attached to hydrogen atoms to have 4 bonds in total for each carbon atom. So we can simply write this structure easily. We have to see that each carbon is having 4 bonds. So if a carbon-carbon has double bond, this carbon needs 2 more hydrogens. This carbon has a double bond and a single bond with another carbon. So it needs 1 more bond. So 1 hydrogen has to be attached here. This third carbon has 1 carbon-carbon single bond with second carbon atom, 1 carbon-carbon single bond with fourth carbon atom. So it needs 2 more bonds. So 2 more hydrogen atoms are attached. Similarly, the sixth carbon atom is attached by 1 single bond with fifth carbon. So it needs 3 more bonds. So we have to write 3 hydrogen atoms with single bonds. So this is hexene. Now the alkene having 7 carbon atoms is called heptene. Hept stands for 7, ene stands for double bond. So heptene is CH2 double bond CH, single bond CH2, single bond CH2, single bond CH2, single bond CH2, single bond CH3. So each carbon atom is stabilized because each carbon atom is having 4 bonds. We can see that clearly here. So this is heptene. Now alkene with 8 carbon atoms. Alkene with 8 carbon atoms is called octane. Oct stands for 8. Ene stands for double bond. So octane's structure is like this. CH2 double bond, CH, single bond, CH2, 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 single bond, CH3. So this is the structure of octene. Now an alkene with 9 carbon atoms is called nonene. Non stands for 9. Ene stands for double bond. So nonene is an alkene with 9 carbon atoms attached by carbon-carbon single bonds, except one bond will be a double bond. So we have a structure like this. CH2 double bond, CH single bond, CH2 double bond, CH2 double one single bond, CH2 single bond, CH2 single bond, CH2 single bond, CH2, CH3. So this is nonene is CH2 double bond, CH single bond, CH2 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 single bond, and finally CH3. This is nonene. And the alkene with 10 carbon atoms is called decene. Dec stands for 10 carbon atoms. Ene stands for a double bond between 2 carbon atoms. So the structure is like this. CH2 double bond, CH single bond, CH2 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 single bond, then CH3. We can easily write this structure. First we write C double bond C, then single bond C, 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 single bond C. Then we see how many bonds are there for each carbon. First carbon has 2 bonds, that is one double bond. So it needs 2 more bonds. So we attach 2 hydrogen atoms to it. The second carbon atom has a double bond and a single bond with another carbon atom. So it has 3 bonds. So it needs 1 more bond. So we attach one hydrogen atom with a single bond to it. Similarly, third carbon has one carbon-carbon single bond, another carbon-carbon single bond. So it has two bonds. So it needs two more bonds. So these two more bonds are formed by the two hydrogen atoms. And fourth carbon atom has carbon-carbon single bond and carbon-carbon single bond. That means it has two bonds. It needs two more bonds. So two hydrogens are attached to it by single bonds. Fifth carbon also has two single bonds with carbon atoms. So two hydrogen atoms are attached to it by two single bonds. Sixth carbon atom also has two single bonds with carbon atoms. So it needs two more bonds. So two hydrogens are attached to it by single bonds. Seventh carbon atom. It also has two carbon-carbon single bonds. This seventh carbon has two single bonds. So it needs two more bonds to become stable. So two hydrogen atoms are attached to it by single bonds. Eighth carbon. Similarly, eighth carbon needs two more bonds. So two hydrogens are attached to it. Ninth carbon also needs two more bonds. So two hydrogen atoms are attached to it. 10th carbon has only one single bond with the carbon atom. So it needs three more bonds. So three hydrogen atoms are attached to it by hydrogens. So this is about alkenes. Open chain alkenes we have studied. Now let us see cyclic alkenes. Cyclic alkenes, they are cyclic structures or ring form of alkenes. Carbon-carbon atoms with at least one carbon-carbon double bond form a ring-like structure. In order to form a ring-like structure, it needs at least three carbon atoms. So the first member of the cyclic alkenes is cyclopropene. So the general formula is CnH2n minus 2. General formula for open chain alkenes is CnH2n. Here CnH2n minus 2. Minus 2 is because of the double bond between two carbon atoms, two hydrogen atoms are reduced. So let us see the simplest cycloalkene, that is cyclopropene. Prop stands for three carbon atoms. En stands for double bond. Cyclo stands for ring form. Why cyclopropene is the simplest form? Because in order to form a ring structure, minimum of three carbon atoms are required. So when three carbon atoms are there, it is called prop. It is also called en because of the double bond. So let's start naming the cyclic alkenes based on the number of carbon atoms they have. Cyclic alkenes with three carbon atoms with one carbon-carbon double bond is cyclopropene. Cyclo stands for ring form. Prop stands for three carbon atoms. En stands for a double bond between two carbon atoms. The molecular formula of cyclopropene, by substituting N is equal to 3. Why 3? Because 3 carbon atoms are present in cyclopropene. And if N is 3, then H2N minus 2 will become 6 minus 2. That makes it H4. So the formula for cyclopropene is C3H4. So the molecular formula for cyclopropene is C3H4. Let us see how the structure is drawn. How to draw cyclopropene? Structure of cyclopropene. This is a carbon atom attached by a single bond to another carbon atom attached by another single bond to another carbon atom. There is a double bond between these first and second carbon atoms. Why did we take it as first and second? Because according to IUPAC rule, the double bond should get the least number on the carbon atom. So the least number is 1. This is 2. We can do it otherwise also. This can be counted as first carbon, this can be counted as second carbon, but this will be the third carbon in every case. So we can count either clockwise direction or anti-clockwise direction. This is clockwise, this is anti-clockwise. Either way we can count. So the first carbon has a double bond and a single bond with third carbon. So totally it has 3 bonds. It needs one more bond to become stable. So a hydrogen atom is attached the first carbon by single bond. Similarly, second carbon also has 2 bonds by the double bond and one single bond with the third carbon atom. So it needs one more bond to become stable. So one hydrogen atom is attached to it by a single bond. So this carbon atom has 4 bonds. This carbon atom has 4 bonds. They become stable. And the third carbon atom has a single bond with first carbon atom and a single bond with second carbon atom. So it has 2 single bonds. It needs 2 more bonds to become stable. So 2 bonds are formed by the hydrogen atoms. So this carbon atom also will get 4 bonds. So it becomes stable. This is the structure of cyclopropene. Now let's see the condensed structure. Condensed structure means nothing but here we have written hydrogens separately. In condensed structure we will combine carbon and hydrogen and we will draw the bonds. So the first carbon will be CH double bond CH single bond CH2 and single bond. So this has become 1, 2, 3 carbon atoms and 1, 2, 4 hydrogen atoms. So the formula for cyclopropene is, we know, C3H4. So we are getting that. Now this can be represented in a simplest form, in a skeletal form. So we can draw a triangle. This corner represents CH because there is a double bond here. This corner represents CH because there is a double bond here. Whereas this corner represents CH2. So totally 3 carbon atoms and 4 hydrogen atoms are present. This is the skeletal structure of cyclopropene. As we go for higher and higher cycloalkenes, skeletal structures are easy to make than to draw this full structure or condenser structure. Let us see cyclic alkene with 4 carbon atoms and 1 carbon carbon double bond. Alkene means 1 carbon carbon double bond should be there. So 4 carbon atoms atomed cyclic alkene is called cyclobutene. So this is the first carbon, this is the second carbon. There is a double bond between them. As a result, they each need another single bond to become stable. So there is one single bond hydrogen. This carbon atom, second carbon atom, has a double bond and a single bond with the third carbon atom. So it needs one hydrogen only. So one hydrogen forms a single bond. Third carbon atom has a single bond with second carbon atom and a single bond with fourth carbon atom. So it needs two more bonds. So it forms two single bonds with two hydrogen atoms. Similarly, fourth carbon atom has a single bond with third carbon atom and a single bond with first carbon atom. So it needs two more single bonds to become stable, because each carbon atom needs 4 bonds to become stable. So it forms two more single bonds with two hydrogen atoms. So this is the structure of cyclobutene. The molecular formula is C4H6 because C4 N stands for 4, H 2N minus 2, that is 4 into 2 is 8 minus 2 makes it 6. This is the general formula. Let us see the condensate structure. As already told to you, condensate structure means nothing. We draw carbon atoms. Since it is cyclobutene, we draw 4 carbon atoms in the 4 corners of a rectangle. Now first we will draw single bonds between each carbon atom. Then we will draw a double bond between two carbon atoms. When we draw two double bonds between two carbon atoms, each carbon atom, that is first and second, needs one more hydrogen. So we attach one hydrogen here, one hydrogen here. Whereas third carbon atom is attached by single bonds to second carbon atom and fourth carbon atom. So it needs two more hydrogens. So we will write CH2 here. Similarly, fourth carbon atom also needs two more single bonds. So we attached two hydrogen atoms here. So it becomes CH double bond, CH, single bond CH2, single bond CH2, single bond CH. This is cyclobutene. Let us see the skeletal structure. That is nothing but skeletal structure means outline. The outline of rectangle is drawn and numbering is given. Wherever we give number 1, we start double bond from there. Double bond is represented in a separating. So there is a double bond between first carbon and second carbon. Third carbon, fourth carbon are joined by single bond. Fourth and first carbon are joined by single bond. Third and second are joined by single bond. So each corner represents the carbon with double bond will have one hydrogen only, and this carbon also has double bond, so it will have one hydrogen. This carbon atom has only single bonds, so it will need two hydrogens. And fourth carbon atom also has no double bond, so it needs 2 hydrogen atoms. So this is the skeletal structure of cyclobutene. Now let us see the structure of cyclopentane. Cyclopentane is nothing but a cyclic alkene with 5 carbon atoms with 1 carbon-carbon double bond and a cyclic structure, that is ring form. Its molecular formula will be C5H8. Anybody can tell that because C5 double 5 is 10, minus 2 is 8. So C5H8. Let us draw the structure of cyclopentane. First we draw 1, 2, 3, 4, 5 carbon atoms. Then we will draw a double bond between 2 carbon atoms. These carbon atoms will become 1 and 2. Then we start numbering them. 1, 2, 3, 4, 5. So there is a double bond between first carbon and second carbon. So they need, and they have a single bond with the fifth and third carbon atoms. So each carbon atom is having 3 bonds. So they need one more bond each with hydrogen atoms. So here is one hydrogen, here is one hydrogen. Now coming to third carbon, it has a single bond with second carbon and a single bond with fourth carbon. So it needs 2 more bonds to become stable. So 2 more hydrogens are attached to it by single bonds. Similarly, fourth carbon atom is having a single bond with third carbon atom and a single bond with fifth carbon atom. So it has only 2 bonds. So it needs 2 more bonds to become stable. So 2 hydrogen atoms are attached to it by single bonds. So it becomes stable. Fifth carbon atom is having a single bond with fourth carbon atom and a single bond with first carbon atom. So it needs 2 more bonds to become stable. So 2 hydrogen atoms are attached to it. Thereby it becomes stable. Let us draw the condensate structure. Condensate structure is based on this. So same structure is drawn, but hydrogen is drawn with the carbon atom instead of showing the bonds. So we write CH double bond, CH single bond, CH2, CH2 single bond, CH2, CH2 single bond, CH2, CH2 single bond, CH. This is the condensate structure of cyclopentane. Cyclopentane. Skeletal structure of cyclopentane. We draw a pentagon. Pentagon has 3 corners. Okay. So here we make a double bond. So the remaining will be single bonds. So the carbons which are on this corners have CH and CH. Other corners will represent CH2, CH2, CH2. So that is the skeletal structure of cyclopentane. This is the easiest form to draw. By the way, cyclopentane is the, I think it is not, but cyclohexene is the most stable form of cycloalkenes or cyclic alkenes. Cyclohexene. It is a cyclic alkene with a cyclic structure and 6 carbon atoms. 1 carbon-carbon double bond is there, and molecular formula, since it has 6 carbon atoms, it will be C6H10. So cyclopentane alkene, that is cyclohexene. Molecular formula is C6H10. Let us draw the structure. So we join 6 carbon atoms by single bonds, and we draw a double bond between 2 carbon atoms, any 2 carbon atoms, and those 2 carbon atoms will become 1 and 2. This 1 and 2 carbon atoms will need only a single bond, so they will be attached to one hydrogen only. Other carbon atoms need 2 more single bonds because each carbon atom is having 2 single bonds with other carbon atoms. So each carbon atom with 2 single bonds attached to other carbons will need 2 hydrogen atoms with 2 single bonds. So the third carbon atom is having a single bond with second carbon atom and a single bond with fourth carbon atoms. So it needs 2 more bonds. So the 2 more bonds are formed by 2 hydrogen atoms. Fourth carbon atom is having a single bond with third carbon and fifth carbon. So it needs 2 more bonds. So 2 single bonds are formed by 2 hydrogen atoms. So in total it will have 4 bonds. So it becomes stable. And fifth carbon atom is having a single bond with fourth carbon atom and a single bond with sixth carbon atom. So it needs 2 more bonds to become stable. So the 2 more bonds are formed by hydrogen atoms. Sixth carbon is having a single bond with fifth carbon and a single bond with first carbon. So it needs 2 more bonds. 2 more bonds are formed by 2 hydrogen atoms. So it gets 4 bonds. So it becomes stable. First carbon is having a single bond with sixth carbon and a double bond with second carbon. So it has 3 bonds. It needs 1 more bond. So 1 more bond is formed by the hydrogen atom. Second carbon atom is having a double bond with first carbon and a single bond with third carbon. So it needs 1 more bond. 1 more bond is formed by hydrogen atom. This is the condensed, this is the structure of cyclohexene. Okay. Now condensed structure of cyclohexene. As already discussed earlier, condensed structure is nothing but writing C and hydrogen together. So first carbon and second carbon have double bond between them. So we write 1 hydrogen each. Third carbon, fourth carbon, fifth carbon and sixth carbon have single bonds with carbon atoms. So we'll write 2 hydrogen atoms. So this is the condensed form of cyclohexene. Let us see the skeletal structure. For skeletal structures, we draw a hexagon. So hexagon has 6 corners. 1, 2, 3, 4, 5, 6. Between any 2 corners, we will introduce a double bond. So the corners having the double bond will become 1 and 2. So 1 and 2 represent CH and CH. 3, 4, 5, 6 corners each represents CH2. This is the skeletal structure, and this is often used in daily practice. In the exam papers also you will get cyclohexene in this form only. This will this structure will be rarely written because it is cumbersome. Sometimes we will see this condensed structure, but mostly the skeletal structure is written for all cycloalkenes. This cyclohexene is the most stable of the cyclic structures. That means cyclopropene, cyclobutene, cyclopentane are not stable because of the ring strain due to less number of carbon atoms and the double bond. But this cyclohexene can withstand the ring strain due to more number of carbon atoms. So it is more stable. So propene, cyclobutene, cyclopentane are not as stable as cyclopentane. Other coming structures will be stable. Let us see the cycloalkane with 7 carbon atoms. This is called cycloheptene. Cycloheptene means cyclic alkene with a cyclic structure and 7 carbon atoms. That is, it is a cyclic structure with 7 carbon atoms and 1 carbon-carbon double bond. And its molecular formula will be, now we can guess, C7 and H12, because 7 doubled will be 14, minus 2 will be 12. So it is C7H12. Now this structure can be written like this. 7 carbon atoms are drawn in a ring-like form and 2 carbon atoms are joined by a double bond. So these 2 carbon atoms are called 1 and 2. The first carbon atom has 3 bonds. So it needs 1 hydrogen. So 1 hydrogen is attached here. The second carbon atom has 2 bonds here and 1 bond here. So it needs 1 more hydrogen bond. 1 hydrogen is attached here. Third carbon atom has 2 single bonds. It needs 2 more bonds. So 2 more hydrogens are attached by single bonds here. Similarly, the fourth carbon atom also has 1 single bond with third carbon atom, 1 single bond with fifth carbon atom. It needs 2 more bonds to become stable. So 2 more hydrogens are attached to it by 2 single bonds. In a similar way, fifth carbon atom has a single bond with fourth carbon atom and a single bond with sixth carbon atom. So it needs 2 more bonds. These 2 more bonds are formed by 2 hydrogen atoms. Sixth carbon atom has a single bond with fifth carbon atom and seventh carbon atom. So it needs 2 more bonds. So 2 more bonds are formed by 2 hydrogen atoms. Seventh carbon atom has a single bond with sixth carbon atom and a single bond with first carbon atom. So it needs 2 more single bonds to become stable. So 2 more single bonds are formed by 2 hydrogen atoms. So each carbon has 4 bonds and it is stable. So this is the structure of cycloheptene. Now the condensed structure, as we have already studied, we simply attach hydrogen to the carbon atoms. So we draw 7 carbon atoms in a ring form and we draw a double bond between 2 carbon atoms. Those carbon atoms will become 1 and 2, and 1 and 2 carbon atoms need one bond each. So we'll write one hydrogen here, one hydrogen here. Other carbon atoms have only two bonds, two single bonds. So they need two more bonds. So two hydrogens are written for each hydrogen atom. So here is CH2, here is CH2, here is CH2, here is CH2, here is CH2. So this is the condensed structure of cycloheptene. Heptene means 7. Skeletal structure. Here also we draw 7-membered ring, heptagon. So each corner will represent CH2, 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 except these two corners where there is a double bond between first corner and second corner, that is first carbon and second carbon. This corner represents CH and this corner represents CH. This is the skeletal structure of cycloheptene, and there is an easiest way to draw a skeletal structure of cycloheptene. This drawing is a bit difficult, but the easiest way is to write like this. One fish-like shape. See, first carbon and second carbon, you draw a straight line. Then you draw a bent line like this from second carbon, bent line from first carbon. So this becomes third carbon. 1, 2. You draw a double bond here. From 3, you draw upward one line, straight line. From this 7th, you draw an upward line. Then you downward line, sorry. Then from there, you draw an upward line, and from here you draw a downward line. Join them here. You get 7 carbon atoms, 7 corners. So each corner represents CH2. CH2, 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 CH2. These two corners represent CH, CH because there is a double bond here. So this is the structure of cycloheptene, skeletal structure. This is easier to draw. You can, if you practice it, you can master it. Drawing these structures will be difficult. You have to erase several times and write. This can be drawn, this structure can be drawn easily. Practice this. Let us see cyclic alkene with 8 carbon atoms. The cyclic alkene with 8 carbon atoms is called cyclooctane. Oct stands for 8. Cyclooctane is a cyclic alkene with cyclic structure with 8 carbon atoms and one double bond between 2 carbon atoms. And its molecular formula is, by now you can be able to tell the molecular formula. It is C8 and double the number of 8 is 16, minus 2 is 14. C8, 14. So we draw a ring, octahedral ring with 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And we draw a double bond between any 2 carbon atoms and we give them the number 1 and 2. Here these carbon atoms are given 1 and 2 because there is a double bond between them. Subsequently this will become 3, 4, 5, 6, 7, 8. So 8 carbon atoms are having, of them 1 and 2 carbon atoms are having double bond and a single bond with other carbon atoms. So they are having each carbon, 1 and 2 are having 3 carbon, 3 single bonds, 3 bonds. So they need one more bond each. So the one more bond is provided by hydrogen atom. Whereas the other carbon members are having 2 single bonds each. Third carbon is having 2 single bonds, fourth carbon is having 2 single bonds, fifth carbon is having 2 single bonds, sixth carbon is having 2 single bonds, seventh carbon is having 2 single bonds, eighth carbon is having 2 single bonds. So each of these carbon atoms need 2 hydrogens each. So 2 hydrogens are forming single bonds with third carbon. Similarly with fourth carbon, fifth carbon, sixth carbon, seventh carbon and eighth carbon. So this is the structure of cyclooctane. Ene because it is having a double bond. Same thing can be written in condensed form. Here we do nothing. We draw a ring-like structure, an octane ring, octahedral or octahedron, and we draw 6 carbon atoms, 8 carbon atoms in the 7 corners of 8 carbon corners of the octahedron. We give a double bond between 2 carbon atoms, they become 1 and 2. So 1 and 2 carbon atoms will need one bond only, so we add one hydrogen here, one hydrogen here. Whereas all the remaining 6 carbon atoms need 2 more single bonds. So we draw H2, 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 H2 here. So the condensed structure represented by cyclooctane is CH double bond CH, CH2, single bond 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 CH. This is the condensed form. Now let's see the skeletal form. In the skeletal form also, we draw ring-like structure with 8 corners, that is octahedron. Between any 2 corners, we draw double bond. So this double bond containing corners will become 1 and 2. So we have 1, 2 double bond. 2 and 3 single bond, 3 and 4 single bond, 4 and 5 single bond, 5 and 6 single bond, 6 and 7 single bond, 7 and 8 single bond, 8 and 1 single bond. So this double bond corners will represent CH, CH. This two single bond corners will represent CH2 each. So this is one CH2, one CH2, one CH2, one CH2, one CH2, another CH2. This is the skeletal structure of cyclooctane. Now the easiest form to draw skeletal form of cyclooctane is easily drawn like this. You draw a straight line like this. Name it 1 and 2. Draw a double bond here. So this becomes an alkene. You draw a straight line above and a straight line below. From here you draw a straight line downwards. From here you draw a straight line upwards. From here you draw a straight line downwards. From here you draw a straight line upwards and join these two by a straight line. So this becomes 1, 2, 3, 4, 5, 6, 7, 8. that is octene because of double bond. So 1 and 2 represent CH each, 3, 4, 5, 6, 7, 8 will represent CH2 each. So this is the skeletal structure of cyclooctane. This is the easiest form to draw. These forms are difficult to draw. We need to erase and draw, erase and draw. It takes time. Whereas this structure can be drawn very easily within a few seconds. Try to draw this structure. Okay. Now let us see the next member of cyclic alkenes, that is cyclonone. Non stands for 9, in stands for double bond. So this is a cyclic alkene with cyclic structure having 9 carbon atoms and 1 carbon-carbon double bond. The molecular formula is C9H, how much? 16, because 18 minus 2 is 16. C9 means H will be double of that, 18. Minus 2 is 16. C9H16. The structure. We draw a ring-like structure with 9 corners. Then we draw a double bond between 2 carbon atoms and name them 1 and 2. 1 and 2 will need one single bond each. So we attached one hydrogen atom to 1 and 2 carbons. Third, fourth, fifth, sixth, seventh, eighth, ninth carbon atoms are having 2 single bonds each. So they need 2 more bonds each to become stable. So we attached 2 more hydrogens to each of these carbon atoms. That is third carbon atom, fourth carbon atom, fifth carbon atom, sixth carbon atom, seventh carbon atom, ninth carbon atom. We add 2 hydrogens each. So each carbon becomes stable. This is the structure of cyclonone. Now let us write this condensed structure. Here also we draw a ring-like structure with 9 corners. And each corner is represented by carbon atom. And we will draw single bonds between these carbon atoms. And we draw a double bond. Double bond is represented in a different ink. And we name these carbon atoms 1 and 2. So the 1 and 2 carbon atoms have 3 bonds each. 1, 2, 3, 1, 2, 3. So they need one more bond each. So we write one hydrogen beside each carbon atom. Whereas from third, fourth, fifth, sixth, seventh, eighth, ninth carbon atoms, they are having 2 single bonds each. So they need 2 more single bonds to become stable. So we write H2 with each carbon atom. That is C3 will have 2 hydrogen atoms, C4 2 hydrogen atoms, C5 2 hydrogen atoms, C6 2 hydrogen atoms, C7 2 hydrogen atoms, C8 2 hydrogen atoms, C9 2 hydrogen atoms. So they all become stable. This is the condensed structure of cyclonone. Let us see the cyclic structure. Cyclic structure, we draw a 9-membered ring and we join 2 corners of the ring with a double bond. So those containing the double bond corners will become 1 and 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 corners. Now, except 1 and 2, each corner 3, 4, 5, 6, 7, 8, 9. Each corner represents CH2. 1 and 2 represent CH each. So this is the skeletal structure. Now let us see how the easiest skeletal structure of cyclononene is drawn. It's very simple. We have to see that. We get 5 corners. So first we draw a straight line, draw a double bond here, name it 1 and 2, draw an upward line, name it 3, draw a downward line, name it 4, draw an upward line again, name it 5, draw a downward line, name it 6. Okay, then from 1 you draw a downward line, draw an upward line, then draw a downward line, then draw an upward line to join here. So when you count these, there will be 9. So these 9 corners represent, except 1 and 2, represent CH2 each. These will represent CH and CH. So this is the easiest structure of skeletal structure of cyclononene, an alkene with 5-membered ring. Let us see the next one. Cyclodecene. Dec represents 10. Ene represents a double bond. This is a cycloalkene. It is having a cyclic structure with 10 carbon atoms and 1 carbon-carbon double bond. Its molecular formula is naturally C10H18. Okay. So we draw a ring-like structure with 10 corners, and each corner we draw a carbon atom, and we draw a double bond between 2 carbon atoms. Those carbon atoms will become 1 and 2. They have 3 bonds, so they need 1 more bond each. So 1 more bond each is supplied by hydrogen atom. So first carbon and second carbon will have 1 hydrogen each. The remaining carbons 3 to 10 will need 2 hydrogen atoms each. So we draw 2 hydrogen each for 3, 4, 5, 6, 7, 8, 9 and 10. So this becomes cyclodecene. Now let's see the condensed structure. Condensed structure is also drawn like that. We draw is 10-membered ring, and each corner we write CH, it's C we write. Between 2 carbons we write a double bond. Those carbon atoms will become 1 and 2. The other carbon atoms, so this first carbon and second carbon will have CH and CH. From 3rd carbon to 10th carbon, they will have CH2 each. This is the condensed structure of cyclononene. Now let us see the skeletal structure. We draw a 9-membered ring with 9 corners. We draw a double bond between 2 corners. These 2 corners will become 1 and 2. The remaining will be 3, 4, 5, 6, 7, 8 and 9 and 10. 1 and 2 corners represent CH each. This is 1 CH, this is another CH. 3, 4, 5, 6, 7, 8, 9, 10 represent CH2 each. This is the skeletal structure of cyclodecene. Let us see the easiest skeletal structure of cyclodecene. We draw a straight line like this, and we draw a double bond here and name it 1 and 2. So this 1 and 2 represent CH, CH. Then we draw an upward straight line, then a downward straight line, then a downward upward straight line. As we draw these lines, we keep numbering them. This is 1 and 2. When we draw upward, it becomes 3. When we draw downwards, it becomes 4. When we draw upward again, it becomes 5. When we draw downwards again, it becomes 6. Now here, we draw a downward straight line. This becomes 7. Then we draw a straight line like this. It becomes 8. Then we draw a line upwards. It becomes 9. And we draw a line downwards. It becomes 10. We join 10 and 1. So it has altogether 10 corners. So it is cyclodecene, because it contains 10 carbon atoms with a double bond. So 1 and 2 represent CH each, 3, 4, 5, 6, 7, 8, 9, 10 represent CH2 each. So this is the easiest way to draw cyclic alkenes. In our next lecture, we shall learn about alkynes. The alkynes are also divided into open chain alkynes and cyclic alkynes. I hope you have benefited by this lecture. Please observe that alkenes contain general formula CnH2n plus 2. Okay, and alkenes contain general formula CnH2n, whereas cyclic alkenes contain the general formula CnH2n minus 2. Thanks for watching my video. Please like, share and subscribe. This is very useful for 10th, inter and even BSc students, because these are the basic things which nobody tells. I hope you benefit by watching this video. Thank you.